So, can everybody hear me? Fine. Oh, you told me to wait for a couple of seconds, sorry. Right. So I wanted to start this talk with a quote from outside of our industry, which kind of is related much. One of the most common mistakes people make is to fixate on the goal or expected outcome while ignoring their underlying behaviors. So this is a quote from Reverse Focus on the reverse mortgages. And reverse mortgage is a home loan that provides cash payments based on the home equity. So usually homeowners defer payments until they sell or move out of this home. And the thing is, one of the most known experts in this industry, recognize that people have a tendency of focusing on the wrong things. So people focus on what will happen with their house 10 years, 20 years later, instead of actually focusing on what will happen from the point on they take the mortgage, right? What will happen next week? What will happen next month? Do they expect the baby? People don't tend to think about those things. They don't tend to think about their behaviors and their lives. They tend to think about their goals. And this is kind of recurring and underlying topic through the entire talk, that we as individuals tend to prioritize outcomes or goals or states over our behaviors or behaviors of others. So I'm Everzet, as Sean said. I'm BDD practice manager at a company called Invika, which is quite a unique position. I think I'm the only guy in the world with this kind of position name. We're hoping to get much more in the next couple of years. I was a software engineer. I'm still considering myself as a software engineer, more on the coaching and training side of things. I'm more known in the PHP community as a creator of BDD and TDD frameworks like Behat, Ming, Prophecy, PHP Spec. I also contributed to Symfony Doctrine 2 and Composer during their lifetimes. So I think that's enough about me. What is this talk about? So this talk about multiple things, and I will try to guide you as naturally as possible through the very complex topic of mocking and test-driven development or growing software through tests. So this talk is about test-driven development with and without test doubles, or mocks, as most of you probably know them. It is about introducing, making sense of different type of doubles. So there is a whole kind of family of test doubles, not only mocks. And people tend to confuse them. I will guide you through each type of the test doubles. Hopefully you will start making sense from them. It is essentially a talk about OOP as a messaging paradigm, right? And at the end, it is a talk about how to design software as a response to message observations. This talk is also about a lot of complex code examples, so sorry for that. I will go through really complex patterns and things like, which is a software design, and it's really, really hard to talk about those things without having complex examples on hand. I try to simplify them as much as possible without losing the message, but you will need to put a little bit of work to bear with me with them. Okay? So it's great, nobody's leaving room. Cool. So first, a little bit of history. So this I believe it all started officially with a big bang, which was this book, Test-Driven Development by Example by Kent Beck. So this book was written in 2002, and it kind of shifted and changed software industry, I believe, forever. And we're still in the transition phase from classical engineering, where either we're not writing tests or writing tests after the software, to actually guiding development of the software with tests. If you look into this book, most of the examples look like this, right? Kent Beck drives you through very simplistic examples of doing things. It is Java, as any other software engineering book. I know it's a PHP conference, so I translated things for you. So what we're doing here, we're doing very, very simple thing. We're creating an instance of $5. We're trying to multiply $5 to 2 and assert that the outcome is $10 indeed. And then we're doing the same 3 times and asserting that the outcome is $15 now. So whenever TDD practitioners talk about TDD, they usually tend to present this kind of examples. Overly simplistic, not really representative. I like to think about TDD in form of something like this, right? Much more complicated example. So what we have here is we have 3 different objects communicating with each other. We have user manager object, which is responsible for registering users. We have event dispatcher, which is responsible for firing an events during this registration. We also have user repository, who is responsible for storing users for the future use. And the thing we're trying to test or develop through test in this particular example is that the event is dispatched during registration. So what we're trying to do is we're trying to make sure that the event dispatcher actually dispatches an event. So what we do, we register our own closure kind of dispatcher. We record the amount of times that call is dispatched. And at the end, we just assert that the amount of calls was 1. This is a key, right? We're doing some job. We're preparing the test case. We're testing the outcome. So this is a very unique way to look at our software. We have 3 objects involved in the conversation. We have those guys talking with each other. But the only 2 things we care about is a starting point and the end point, right? Where did it all started, what method we're calling, and what's the outcome of this method. The thing is, there is potentially 5, 10 million different ways how to make this code work, right? Including switching from tabs to spaces. And the thing that we're kind of losing track of when we're doing this classical TDD approach is how can we see those things, right? How can we see all those different methods? And what's more important, is it an outcome? Is it those 2 points, A and B? Or is it all those different options and the option that we chose? So in the words of classicists, life is a journey, not a destination, right? Psychologists and classic literature gods a long time ago defined that our human lives are defined by the journeys, by the things we're doing in them, not where we end with them. It's more important how you approach problems in your life than how you solve them. What if the same thing applies to software engineering? What if the outcome is less important than how you achieve it? So as a matter of fact, I'm not the first guy, nor I'm the last guy that came up with this. And a couple of guys of the names Steve Freeman and Nat Price came up with essentially the same idea. They wrote a book called Growing Object-Oriented Software, Guided by Tests, famously known as Goose Book, somewhere in 2009. And this book was focused around the idea of journey is more important than the destination. So what those guys did, instead of looking at the outcome of our call, instead of looking at the outcome of our conversation of the objects, they started looking at the objects themselves. And they started to ask very interesting questions, like, if we have a dispatcher and repository here, where's the message? Where's the conversation? And there is no conversation here. So our tests don't show conversations of the objects. They don't show how our objects talk to each other. They don't show how we get to this point. And how we get to this point is essentially an important bit. But is it? Is it really more important than the state, right? Because we know software engineering is all about outcomes. We're providing some complex formula. We give it some input. It produces some output. Output is the most important thing in the world. Well, we all are writing PHP. I hope we're writing object-oriented PHP. So I can talk in the area of OOP. And for godfather of OOP, Alan Kay, who's essentially coined the term OOP. OOP is only messaging. It's not about state, it's not about outcomes, it's about how different systems or objects are talking between each other. That's OOP. OOP is not about getting from point A to point B, it's about how you get there. It's about designing systems which perfectly communicate with each other and communicate in the way that makes sense both for you and ideally for your business, which is DDD. So if communications are important, if those conversations are the keystone of software engineering, how can we observe them? So we have an interfaces, right? So we can define login messaging, input messenger, couple of methods there. That's our conversations, right? Those guys are talking about this. Well, yes and no. In my opinion, interfaces is just half of solution, because in my opinion, interfaces just define a topic of the conversation. They don't define how this conversation will unfold, right? So if interfaces are topics, then tests with test doubles are examples of those conversations. So what you want to get in the end is you want to get tests which represent those communications in the form of examples. So in this case, this object should tell this object to do this thing, and also that object, when called, should return this thing. That's the communication we're interested in. And the solution to expose this communication in addition to interfaces is doubles. There are 5 mostly known test double patterns in software engineering. There is dummy, there is stub, spy, mock, and fakes. I will guide you through all of them and explain what's the difference between them and where you need to use each one of them. The reason why I'm doing this is because later on I will show how mocking or doubling your code actually helps you with design, and I can't do this without you understanding the difference between different doubles. So the framework we will use today for examples is a prophecy. It's the framework that I wrote. It's the framework that I feel most comfortable with. It doesn't mean you need to use it. You can use it with PHP unit. It is a heart and central piece of PHP spec, but you can use it anywhere. And most of the examples and things that I will talk about today are essentially applicable to mockery, somewhat applicable to PHP unit mocking framework, even though you need to put a little bit more effort there. So how to use PHP prophecy? It's essentially very, very easy. The 2 things you need to keep in mind are there are 2 objects you need to start from. You have a prophet and you have an argument. So prophecy have this really interesting ubiquitous language where it presents mocking as a way to predict the future. So in the prophecy regard, the thing that creates mock is a prophet, and the mocks actually, or doubles, are prophecies of your object's behaviors. So you're predicting how your objects will talk in specific nature. So you're creating prophecies of object communication. So first of all, in line number 3, you create a new prophet. On line number 4, you create new instance of prophecy for user interface class, or just user interface. So user prophecy equals prophet prophesize. This returns you a new instance of controller for prophecy, right? So prophecy for the objects. On the prophecy, you can say change name everZ should be called. That basically defines your expectation of this method be called in the future. Then you reveal the prophecy, which returns you actual mock of the user object. You call the method, and you check predictions. If predictions did happen, no exceptions will be thrown. If this call did not happen, if we didn't call this thing, check predictions will throw an exception. That's it. That's all there is to it. There is nothing more. There is no bootstrapping outside of this thing. You can just take it and use it in your PHP unit test cases if you're into it. So what about different types of test doubles? Let's start from dummy. So suppose we have a code like this. So we have a system which is responsible for authorizing users and also counting the amount of logins users did. So the first thing you want is to get authorizer as a constructor argument to this guy. And also the login count by default will be 0. So the first test you want to write is test that newly created system has no logged in users, right? Just like very simplistic success case. So in this case, you don't actually need to do anything with authorizer because you're not trying to authorize anyone. You're just testing default case. But you can't construct the system object without passing an authorizer object here. So you need to create a mock, or dummy in this case, of the authorizer class. And then you just pass it to the system. So that's essentially what dummies are. Dummies are just tokens of objects you don't care about, but you need to pass around in order to fulfill type hints. You don't care what will happen with them. Whenever somebody tries to call a method on the dummy, it just returns null and nothing happens. Then there is more complicated kind of doubles, stubs. So let's say we have a little bit more complicated functionality now. Now we want to test that login actually logs in user and increases amount of logged in users on the system. The way you will test it is similar. You again call the same two methods. You create authorizer prophecy. You pass a mock into the system. But then you do an interesting thing. You're saying that authenticate, authorizer, authorize with those arguments will return true. Right? You're saying that authorize on authorizer with those arguments, when called, if called, will return true. And then you make a call, and you assert that your login count changed. So this is what makes your double a stub. Stub essentially is a double that, in case of called, produces some specific or expected behavior. Nothing else, nothing more. Then there are spies. So spies, again, it's a little iteration. So not only you want to increase amount of your login count on the system, you also want to record the login into some login timer. And in this case, you actually do care that there is some communication happening. Until this point, you didn't care that some method is called. Right now, you're starting to care. So the way you do this with spies is you're saying, after you made a call, record login with this argument should have been called. If it wasn't been called with this argument, it will throw an exception. That's what spy is. Then there is a mock. Mock is nothing else as just glorified versions of spy. So you have this implementation which is a spy. You made a call, you're making a check that message was sent. You can change it to be a mock by doing this, right? Before a call, you're saying, in the future, this thing should be called. And then you're doing this thing, check predictions. And check predictions will throw an exception if this method wasn't been called. Usually, testing frameworks do this thing for you transparently, so you don't need to worry about this. In PHP unit, for example, there are no spies, or wasn't. There were no spies till recently. In prophecy, spies are the first-class citizens, and essentially mock is just a different version of an interface to the same thing. And then the last version of the doubles are fakes. So fakes are not really doubles created by the mocking framework. Fakes are just very simplistic implementations of your classes. You create them manually. So for example, if you have a system boundary, which is database connection, or third-party API connection, or mailer connection, you don't want your integration tests or acceptance tests to actually talk with the mailer or talk with the database. You want to speed things up. So in this case, you implement fake implementation of your authorizer, which doesn't do really anything complex. Okay, does it all make sense? Okay, all right, the boring stuff is past. So there is kind of predefined way to look at the doubles nowadays. Doubles are a way to isolate things. So this is where, for example, most of the rage of DHH comes from, and most of the misunderstanding of the modern TDD practices come from. People look at doubles as a way to isolate them from really slow things, right? Doubles are the way to make tests very fast. doubles are the way to isolate your units from entirety of the system. Well, the ridiculous and stupid thing about doubles is the guys that created doubles had different intentions in their minds. So actually, the Goose book was written by London XP, one of the members of London XP community, two of the members. And they coined mocks. They created mocks. And they created them for a little bit different purpose. So there is a quote from one of them. At the time, we were struggling to promote the idea of using mock objects as a design tool. Many people saw it only as a tool for speeding up unit tests. People still see mocks and doubles as a way to speed up unit tests. And that's a problem. And that's why there is so many misunderstandings, and that's why there are so many tests that couple you to the implementation. Mocks, when used as design tool, they don't tie you to implementation. They actually help you to design things in the way you would want them to be designed. So if we look back at the event dispatcher, and we look at our two objects that we're interested in seeing, communicating, the way we will refactor this thing to actually check that dispatcher receives a call to dispatch things makes the test not only more readable, it makes it more simple. So also, as you can see, there is no state assertion. We're not checking that some guy has an output. The only thing that is important for in this case is that there is a call, there is a message, there is a communication happening between two objects. There is a fact that even dispatcher dispatch with those specific arguments being called. We're exposing communication between objects. Okay, so the question is, what does it all do with design, right? So we're doing kind of controversial and tricky thing where we had hidden communication between objects, hidden conversation, and now we're exposing it. How does it help us to design things? Well, I believe that if you expose something, problems become apparent, and when problems become apparent, it becomes easier to fix them. So there is a common effect in the physics called observer effect, which essentially states that observing something will influence phenomenon being observed. So observing some problem, you will eventually fix it. And this leads me to the solid principles. So as a way to illustrate how mocking or Goose book approach to testing changes the way you design things, we need to find a way how to talk about design in a very argumentable way. So the only way I can talk about design without implying personal preferences is to talk about design principles which somebody else defined for me, which is a solid principles. So what we will do now, we will go through a set of 5 examples where I will show how exposing communications between objects make it easy to spot the problem, make the problem apparent, and also guide you towards the way to fix this problem, fix the solid principle violation. Okay? So the first case I want to provide, I know it's a Laravel conference, but I won't provide really common case from the Symfony community. Controller that guys are using all the time. I bet you have something like this, not in the controllers in the service layers, but you've seen something like this before. I bet you did. So we have very simplistic controller here, right? So we get repository, we create a query on this repository from the controller, and then we render a response. So the thing it does very, very simple query to get packages for the specific maintainer, which is our user, and then generates a packages HTML using Twig. And the thing is, it's very, very easy to write this code because there is a base controller in Symfony that you can extend, and you can use functions like this render, this get doctrine. But as soon as you will start trying to unit test it, and I know that's a crazy idea, unit testing controllers, but bear with me for a second. If you try, that's what you will get, right? Crazy notion. That's why we're not unit testing controllers, by the way, right? Because then we end up with this thing. So you can just be scared, close it up, and never unit test your controllers, just integration test them, right? End-to-end test all the way. Or you can just try to listen what tests are actually telling you. So what do they tell us? Well, they tell us there are at least 10 collaborators, 10 different objects this guy is talking with, 10 different objects this guy is aware of. Even more crazy than that, there are 7 different messages this guy is saying to other objects. Not only he knows about 10 guys, he also talks with 7 of them. This is a single responsibility principle violation. Single responsibility principle violation says that whenever you will try to change one of those guys or refactor one of those guys, you will need to change every single controller action you have like this. And just because you have 10 of those guys, the chances of you changing this action every single commit just grow exponentially. That's why single responsibility principle violation is considered a bad thing. How can we improve that? Well, if you try to write mocked test, which makes absolute sense, and it's easy to read and easy to understand, you will end up with something like this, right? So you just expose package repository, so you make your controller dependent not on the service locator, but on the specific interfaces. And then you do one message that you care about, right? You're trying to get from the repository gate maintained packages ordered by name. That's all you care about. So number of dependencies goes down from 10 to 5, and number of messages goes down to 2. The coolest thing with this is people have a tendency of believing that when you're trying to write mocks, when you're trying to isolate things, when you're trying to expose communications, you end up with more moving parts in the system. You're ending up with more code. The truth is, you don't. You end up with more concise, more readable code in your controllers if you try to unit test controllers and expose communications between objects there. Just by exposing this mess you had there, you just discovered that there are 5 different things talking between each other every single time you're calling this action. And just by making an action of simplifying this through tests, how can you simplify this communication to be more concise and readable? You improve the actual code of your controllers. Now, every time you need to change your repository or other objects in the system, and you're not touching this particular method, you don't need to change your controller actions. Second case, basket checkout. So let's say we have this very simplistic basket, and the thing that it does, we pass an order processor to it during checkout. So it creates a new total price, iterates over the all items in the basket, which we added there before, and essentially calculates the total price and adds the item to the processor. Then it creates a new cash payment from the price, sets a payment to processor, and asks processor to pay. If we write a spec for this, or test with mocks, it will look like this. Well, nothing horrible. Everything is fine. Everything goes along. I wouldn't change anything in this test case until I get another one. So we have a test checkout with cash, and now we need to introduce another functionality. We're planning to allow people to pay for their baskets with credit cards. If you look at those 2 cases, they seem very, very similar. The way we handled this problem is we introduced 2 different versions of the basket. One is for cash, not credit cards, another one for credit cards. And then we just check that there is a proper communication happening later on. So this, when you have these similarities in your test cases, when your multiple test cases look exactly the same, that's not the reason to panic and go away and say like, oh, I'm not writing tests for this thing anymore. It's a reason to go back to design principles and basically understand that you have open-closed principle violation. Open-closed principle says that software entities, including classes, modules, functions, should be open for extensions but closed for modification. Which means every time you want to add credit card or maybe PayPal payments, you don't need to change this method. you don't need to change your basket, but you do change it because every time you add it, you add new property to your basket. And that's what those two tests actually highlighting. You have this issue because you have this symmetry between them. So how would you refactor it? Well, we introduce payment method, right? Payment method is a factory which creates specific payment methods depending on what kind of factory it is. So payment method accept payment will return a new instance of the payment. So this way, you just add additional argument to your checkout in the basket. And when you need to create a new payment, you just call accepts payment on this method. Every time you want to introduce now PayPal or another payment provider, maybe you're moving in a different country, the only two things you need to implement is a new payment method instance and a new payment. That's it. This thing, basket, doesn't change, processor doesn't change, nothing changes except your new payment method. Seeing symmetry between test cases exposes this problem and allows you to simplify things further. And even the test case shrinks down to a very, very simplistic one. So there is the third case, which is, bear with me, really, really complex, but I will try to explain it as best as I could. So this is a case from Mink. Mink is essentially a browser emulator. So it kind of pretends to be a real user browser. And it does this by talking with real browser drivers behind the scenes. So it can talk with Selenium, which will start the Firefox, actually do things in the Firefox when you're telling it to go to somewhere. Or it could use like Guzzle behind the scene. So Guzzle will just go to the URL when browser tells it to. So the way it is implemented is we have a browser class, which depends on the browser driver, right? And when we're asking our browser class to do something like go to the URL, it asks driver to boot something up, and then it asks driver to visit some specific URL. So the way you will implement Guzzle and Selenium will look like this. You have one interface, which is a browser driver, which has both boot and visit URL. And then you have Selenium driver implementation, which asks Selenium to start browser on boot and visits the URL. And then we have Guzzle driver implementation, which is really, really interesting because we have a visit, but we don't have boot. That's because we don't need to boot Guzzle, right? There is nothing to boot. It's just like PHP script that executes in the background. So then we write a test case for our headless browser driver, or Guzzle. And then when we run it, magical thing happens. Prophecy throws an exception. An exception says, even though you're expecting only the visit URL to be called, when you're asking browser to go to, it actually calls both boot and visit, and you didn't expect to call boot. So this thing in software engineering or in refactoring design practice is called refuse bequest. So what is refuse bequest and why it is a problem? So let's look at our Guzzle driver. So our Guzzle driver, when you ask it to visit, it just opens the URL. But then, what if one of your tests or functions actually use those drivers independently, right? What if you're interchangeably? So what if you can use both Selenium driver and Guzzle driver? When you need to, you can change and mix and match them. But the problem is, if you start using browser with Guzzle driver, you might start calling visit function before you call boot, which will work with Guzzle, but as soon as you switch to Selenium, it will stop working. That's what refuse bequest is. You have a part of the interface, part of functionality of the driver, which is not implemented by this particular implementation. So what you do in this case, well, you bring awareness of the booting to your Guzzle driver. So now suddenly your Guzzle driver requires you to boot it. The problem with this thing is every time you implement new driver, so let's say you want to implement Gut driver, or you want to implement Phantom.js driver, which is also headless, every time you implement new driver that doesn't require boot, you need to do those things. So all your drivers that don't need boot suddenly became aware of boot. And this is Liskov substitution principle violation. The way you solve this is you completely separate two interfaces. You say there is a browser driver which knows how to boot things, which knows how to visit things, and there is a headless driver which just visits things. So now you might think, okay, now we need to update our actual implementation of the browser, so it knows about two different versions of the drivers. What if we implement third version of the driver? Well, we need to update browser again. Well, you can use design patterns to help you with that. You can introduce adapter. So you have your Guzzle implementation, which implements headless browser driver, and then you have headless browser driver adapter, one particular class, which adapts every single headless driver to be a browser driver. It knows about boot, but only he knows. It's kind of you localized all the dirtiness of your adaptation layer in one particular class. So now, every time you need to implement new headless driver, you just implement the interface and you just use it, and adapter will adapt all of them to the classical browser driver. Browser doesn't know about the fact that there are headless drivers. Headless drivers don't know about the fact that there's a boot function. This thing handles all of that for you. And that's essentially how you solve it. And the reason why you solved it is because Mocking tool notified you about refused bequest. Refused bequest is when you're calling a method that you didn't expect, or when the code that you're calling calls the method that you didn't expect it to call. Does it make sense? Starting to lose you guys. Okay, the last one. Not the last one, but it becomes easier from this point on. So let's say we have a messenger. So this messenger is responsible for interacting with credit card backing. So we have ask for card, ask for PIN, ask for account, ask for amount, and tell there are no money or tell that machine is empty for money, right? It's just like ATM interface. So let's say we implement the functionality or behavior of test ATM asks for a card and PIN during login. So we're mocking our messenger class, and we're saying messenger ask for a card should be called, and messenger ask for PIN should be called. So the thing that mocking tool wouldn't help you here much, but what this test makes really, really apparent is that even though you expect only two methods to be called, you mock the entire class with 6 different methods. So this is interface segregation principle violation, right? It says that your method, your behavior, forces you to depend on every single message that actually doesn't need. What you do in this case? Well, you introduce login messenger, and you split one big interface into 3 smaller ones. So in this case, our login messenger just have those 2 methods that we actually use in our tests, right? Again, very simple violation, very simply highlighted when we're writing test for it. So the last case, entity repository, and this is really, really interesting one. So what usually happens in Symfony and Doctrine, and I bet it happens the same way with Laravel and Eloquent, is that you have your own version of the repository, which basically delegates calls to the parent repository by extending it. As soon as you will try to unit test it, this is what you will get. Again, the same problem, right? There's too many objects this guy knows about now. But that's not even the problem we're looking at. The problem is we're not testing anything. The problem is we're actually writing tests for our object talking properly with Eloquent, or Doctrine in this case. How are we sure that Eloquent actually properly responds to that? We don't own Eloquent, right? Maybe it changed yesterday, we updated it, and even though we're talking with the guy properly, how are we sure that this guy returns to us properly? We're not. So this thing doesn't prove anything because you don't own both sides of the conversation. This is from where the rule "do not mock things you do not own" came from. If you look at this and you will try to think about solution, the solution is very simple. It's dependency inversion principle, right? So what you do is you introduce your own domain interface, job repository, which is responsible for finding jobs by name. And then your doctrine job repository just implements it. So what you do from this case on, every time you want to have your job repository be involved in any conversation, you mock the interface. If you want to test your doctrine job repository or Laracon job repository, which is particular implementation of this interface, you just integration test it, right? Write PHP unit test, don't mock anything, just test that this thing puts things to the database and returns things from the database. So there's a recurring topic with exposing outcomes and exposing communications. There is an interesting observation I have after seeing different styles of TDD applied to different kinds of projects. And the observations is whenever you're exposing, actually influences your design. And it actually influences the way your design becomes verbose. So people are kind of nagging that exposing communications or mocking everything makes you create too many collaborators or too many objects in the system. And that's kind of the bad thing, just like you have too many things talking between each other. But that's because you care about communication. If you care about conversations, and if you expose those conversations, that's what you end up having. You have more conversations. The thing that people miss is that exactly the same or symmetrical thing happens when you're trying to expose outcomes. Classical TDD is all about exposing outcomes. You're doing you're calling some method, this method does some job, and then you need to assert the outcome. How do you assert the outcome? You add getter, right? What if you don't need this getter anywhere except tests? You still need to add getter. So exposing outcomes will force you to add more getters into your code base. Exposing communications will cause you to have more communications in your code base, as simple as that. And you choose what's more important for you, or what's the acceptable trade-off. Important note to have here. First of all, do not use broken mocking tools, right? I've discovered recently during Adam's talk that PHP unit doesn't actually tell you when you're trying to mock non-existent method on the interface or class. That's horrible. Either configure PHP unit to not do that, or use proper mocking tools. Do not fake value objects. They're just values. Create them in place, use them in place. The practice that I use to enforce this across the code bases we have is just essentially make the value objects final. Then you can't mock them. None of the known mocking tools in the PHP can mock final classes. So make your value objects final, nobody will mock them. Do not fake collections. They are just collections of objects, just use them, right? It's the same as with value objects. Do not parts of the objects, decouple them. So as soon as you want to introduce partial mock, this is a hint or a drum beat for you to introduce decoupling. So what you're trying to do is you're trying to say, okay, part of this object I'm not caring about at the moment, but another part I do care about. You have two objects in one. Separate them. And the most controversial and crazy bit, do not use mocks for isolation. If you do use mocks, use them for design, right? Use them to expose your communications so they can be made better. Mocks weren't being created for isolation. If you want to isolate things, introduce fake if you want to speed up your tests, implement fake implementation of your repository. You don't want your tests to talk with the database. Well, write a fake test class write a fake implementation of repository that just writes things to the memory. And that's it. That's as far as you need to go with speeding up your acceptance tests. Do not mock things for isolation. Mock things if you care about communications between objects. So a little recap. State-focused TDD is not an only way to do TDD, right? Just make your call. There is no right or wrong. Camp of guys that are into state-focused TDD is a little bit bigger. So it is Martin Fowler, it is Kent Beck, it's Uncle Bob. The camp of guys that are into messaging TDD or communicational TDD are Nat Price, Steve Freeman, Dan North. Messaging is far more important concept of OOP than the state, even if you're doing state-driven TDD. By focusing on messaging, you expose messaging problems. That's the key thing for you to take away, right? By exposing something, you expose problems in the something. By exposing messaging, you expose problems in the messaging. By exposing state, you expose problems in the state. What's more important for you? Your call. By exposing messaging problems, you could discover most of the solid principle violations before they even happen in your code. That's why we do TDD. Not because it's a fancier, like really fun way to write tests. That's why. Because we want tests to help us design system, not only to test it. There is a fifth part of this. Messages actually do define objects' behavior. And that's why I'm talking about this whole thing here. Because behavior is kind of my life interest. That's what I'm doing for a living. So BDD is not only about BHAT or writing user stories or scenarios, how people use the system, how people interact with the system, how the system interacts back to the people, and how people talk through the system. It's also about how objects communicate inside the system, how they talk between each other. By exposing both, you improve both of them. Any questions? Yes.
Hi.
Hi.
You mentioned that you don't mark things that you don't own. How would you go about if you're depending on third-party APIs, for example?
Yep.
Like in a situation like you use S3 or
right.
whatever.
So the first question will be, what do you want from this S3? So you want it to do something for you.
Yep.
Create an interface, create an implementation of this interface which talks with S3, write an integration test for this particular implementation, mock your own interface. Does it make sense?
Yeah, but still, then I need to test that implementation as well, and then
yeah, you write an integration test. So integration test is a PHP unit test case, for example. It could be any testing framework. PHP unit really fits there, which instantiates this particular class, calls method on the class, checks that checks, for example, that put file on S3 actually adds file on S3. But only this particular guy. So your integration test boundary, which you created yourself, and you hide boundaries behind the interfaces which make sense for your domain, right? You're not using S3 in your system. You're actually using something that stores files in the cloud. Yeah. So in your system, if it makes sense, you name it like file system storer or file system cloud, and you have some methods that make sense for your domain on this class. And then you implement on this interface, and then you implement this interface with something that uses S3, and you integration test this something, and you unit test everything else.
Yeah, gotcha.
Cool.
Thanks.
Ooh, Taylor.
Just following up on the S3 thing, is it like the integration test to make sure it's actually on S3? Should we go ahead and write that, or should we just trust the S3 people that they have already tested that their PHP SDK actually does put files on S3, like they have their own integration test?
Right.
Or would you recommend actually writing, in addition to whatever test they have, our own integration test that says, yeah, files are actually going to S3?
That's a good question. I think it depends on complexity. So for example, you have your own interface which makes sense for your domain, and then you have implementation of this interface which uses S3. So if everything that this implementation does is just like proxies 1, 2 calls to S3, I wouldn't go like as testing it. But if it's just like, if inside it calls like 5 different methods and changes behavior based on like what you input from the interface, then I would integration test. I wouldn't test how S3 works. I would test how this particular class works with this S3 adapter.
Okay, so if you're doing like a series of operations on
Yeah.
S3, you would integrate. Okay, that makes sense.
It's all kind of guided by how confident you are with the code. So as soon as you're like getting less confident, like I'm starting to get afraid that this thing will break. This is where you're introducing an integration test.
Okay, thanks.
Raphael, we will add annotations, don't worry.
Good. Oh, that was the question. No, so you mentioned using fakes instead of mocks.
Right.
For that all over the place. So this is more of like so where do you put your fakes in terms of namespacing and within the test? It's more of a
right. So like I don't put fakes into the test's namespace. I usually put fakes into the fake namespace into our actual domain, because the assumption is like I usually use them purely in acceptance tests. Because I want to make my acceptance test fast. So like there's 2 options. You can use real implementations with your acceptance test, like I'm talking behat, for example, but then your acceptance test will get slow. Or you can use fake implementations of your boundaries with acceptance tests. Your acceptance test will be really, really fast, and then you write integration tests for those boundaries separately. So I put them into fake namespace, like it's actually called fake, in the actual domain. And this is where those guys live. The assumption is I might at some point want to use them outside of the tests, because most fake implementations, they are real implementations, but they're just very simplified. So for example, if I'm talking about repository, it's just this thing that holds an array of objects. So when I'm asking repository, like in-memory repository is a good example of this. So save this object for me, and it just like stores it on itself. So I might want to use it like for demonstration purposes outside of the tests. And so like it doesn't make sense to just limit it to the test namespace. Cool. Any more questions?
I have a question.
Yeah.
So you mentioned using your mocking tool, and you can look at your test and count the number of objects involved.
Yeah.
You can detect Liskov substitution principle violation, or even more importantly, rather, interface segregation principle violations.
It's not automated. It's not happening automatically.
Yeah, I was just wondering if there was value to automating some of this. So you could see how many messages are being passed in the test. You can see how many objects are being involved. And you can see if you're calling methods or not calling methods on the interface that you're mocking.
Yeah. So currently what happens in Prophecy, and I believe it happens only in Prophecy, when you're saying that you're expecting this particular call on the object happen, but you're not saying that you're also expecting that other call to happen. And when you start conversation between objects and then like both calls happen, Prophecy will throw an exception saying like, hey, you didn't expect this call to happen, but it actually did. This highlights refused bequest, and this highlights on its own to the Liskov substitution principle violation. Interface segregation principle violation is kind of similar. It just works in a different direction, where you are calling some methods on the interface. You're calling only those methods, but the interface has like 5 more methods that you're not calling. So there is a thing that I'm thinking about adding, but it wouldn't be violation, it wouldn't be exception, it will be probably like warning or something, because I bet your code bases will get just really, really scary or crazy when every single interface will throw an exception whenever you're not calling some method on it. Essentially, the idea is whenever somebody uses your interface, as much methods as this guy uses, this interface should have. Does this make sense? And yeah, I'm thinking about this. It's really hard to automate and enforce it from the tool perspective. Tool kind of, at some extent, not tool, but like testing with mocks exposes this problem. It kind of make it visible. It doesn't highlight it as a problem just yet. So I'm in the thinking. It's hard to do. Did that answer?
No more tests or questions?
No more tests.
No more tests for every set?
I hope I didn't scare people that much.
I have a question about the mockings for, not like you are suggesting the mocks not to be used for isolating tests, to make fake classes for testing something that you want to isolate.
Yep.
As far as you understand, that means that when you build a mock for designing, as far as you finish the designing process, you just finish the development, you just delete that mock and you use the fake class?
No, I keep the mocks. It's just like they are. It's a difference of intention and benefits. So my initial intention of using mocks is I use them to design, to expose messaging and expose messaging problems, to see how objects talk with each other. As soon as I've done with design, I have a test which actually tests those things working later on. So I don't change anything. I have a test that checks communication between those objects in the future and that it happens properly. So I keep mocks. It's just I use mocks for tests, but after I wrote tests, if it makes sense. So I'm not using mocks for testing. I'm using mocks for design. But then later on, like, they are natural test tools.
Thank you.
Does it help?
Yeah, I think so.
Okay.
Okay, last call.
You seriously need to have your own mic.
I like to engage. TDD is something for me that's been a really big problem. More often than not, if I identify that I need something, I'm not really sure how it's going to work out in the end. I kind of have a bit of a play with, a bit of code, see if I like the implementation, and then if I don't like it, then I kind of change it around and then write out my test. Obviously, TDD advocates would be quite against that kind of approach. I'm kind of curious how you actually, if you actually do use TDD right from the start, or you have kind of this little bit of a playground first, or if you don't, how do you kind of bridge that gap between knowing what's going to kind of work for you in the end?
So there's two misconceptions. Like TDD practitioners, at least the guys that spend quite some time with TDD, are totally fine with you not doing TDD. That's kind of, nobody will bash you for that. TDD practitioners, in case where it's really, really hard to TDD something that you don't know. So in those cases, like, it's fine to try ideas without writing tests first. What crazy TDD practitioners like me, Marcelo, doing in this case is just like, after we found this like good implementation, after we found out what we actually need to do, we just scratch it out and test drive it. You don't need to do it. You just need to. You can write tests afterwards, but that's approach to do this. Generally, like, how do you define when you use tests or not? I use tests most of the time. I write tests most of the time before I'm doing something. But that's because I kind of finished transition into TDD where I'm thinking in tests, right? So just like when I'm writing tests, my intention is not to write tests. My intention is to see how those two objects will talk between each other and what's the outcome of this will be. So I'm saying like, okay, so this guy will call this guy. Okay, and probably that guy will return this. Yeah, that might work. Run the test, right? So I'm thinking, I'm arguing about the code in tests. And what happens is, like, when you see the teams working in this, like pair programming especially, you start seeing the cases where like people not even talking about the code. Like, they sit next to each other, looking into the screen, and just like one writes test, writes specification, and I was like, that's interesting. What if that? And it's just like, like they're conversating through their IDE or text editor in form of these messages. They don't need to outline this. Like, that's a design tool for them. That's essentially how I use it. But it took some time to shift mindset. Does it answer the question? Cool. Okay.
Yeah, I think that might be all the questions.
Okay. I will ask you then to leave a feedback here. That's the way I can improve this talk. I kind of like this talk, so probably I will deliver it somewhere else. So please leave a feedback. And tell me what I can improve. or tell me that I don't need to improve anything to break it. Thank you very much.